Hi everyone, welcome back to our control system course. So in last class we discussed about that first order system behaviors. What is the standard transfer function for the first order system? Good. K divided by tau s plus 1. So let you assume this is the response of your system. Is it possible to identify the transfer function for this system? It is the response of the first order system for a unit step input. Is it possible to get that transfer function? Good. What is the gain value? What is the definition for the gain? Yes, output divided by input. In steady state output, the system is settled at 1, isn't it? Output settled at 1. So the input for the system is unit step. So gain value means K value. The formula for the gain is the output divided by input, that is 1 by 1, 1. Okay. So then the next step is we are going to find out that tau value. How is it possible to find out the tau value? Yes, good. So for this steady state output value is 1. 63.2% of that steady state output is 0.632. That 0.632 is achieved at one time constant, isn't it? So this is the time constant. That one time constant is the tau value. So in here the transfer function is 1 by ts plus 1, where the response, output response is settled 1. In which time it is settled? At 5 time constant. The output is settled at 1. Okay. So the transfer function for this one is 1 by ts, and it is a one gate question. In the year 2010 they asked for the system 2 by s plus 1, approximate time taken for your step response to reach the 98%. So if you are knowing about this 98% at 4 time constant, the output is in 98%. So in here the time constant value is, yes, good, tau s plus 1, K divided by tau s plus 1. K is 2 for the given system, the K is 2, tau s plus 1, the coefficient of the S is the 1. So 1 is a time constant. But what they are asking, 98%. In 98%, when it will reach the 98% at 4 time constant. So the tau value is 1. For the 98% of the final value is 4 seconds. Suppose they may be asked about that 75%. What is the time period for that reaching the 75%? It is the 75%. In that case, you may have to follow this concept. So in here we are applying for 98%. For the 98%, we are getting 3.91 second, approximately equal to 4. 4 is the correct answer. Okay. So in this class we will go to discuss about the second order system. Later we will consider that standard transfer function for the second order system, that is without 0, that is there is no component, 0 component in system. Open loop transfer function for this one is omega n divided by s into s plus 2 zeta omega n. We are going to find out that closed loop transfer function. We are knowing about the transfer function formula, that is closed loop, negative closed loop feedback loop formula. Forward path element is this one, 1, and plus, due to the negative feedback the sign is the plus, and forward path element in multiplying with feedback path element, the feedback path element is 1. There is no dynamics in the feedback or unity feedback, that's why 1. So after getting the simplification, first we will take the LCM and algebraical simplification. We are getting this as a standard transfer function for the second order system. In here, two parameters is there. One is the omega n and another one is the zeta. Okay. So in that zeta is nothing but called as the damping ratio, which is as a measure of the degree of resistance to change in the system. Okay. So in live class, face-to-face class, I mentioned the mechanical system by using that chair, isn't it? Remind about that. Omega n is called as that undamped natural frequency. Okay, so it is the oscillation of the system. So without damping, without considering the damping, what about its oscillation is represented by that omega n. Okay, the closed loop pole for this system. We will consider the characteristic equation of the system. This is the characteristic equation for the second order system. So if we find out that roots for this one, this is the two roots. So based on these two roots, hope that minus b plus or minus root of b squared minus 4ac divided by 2a, that formula is well known to you all. So you can easily able to find out that the roots for the second order polynomial. So that root is this one. So depending upon that zeta value, we may categorize the system in four manner. Okay, so we will consider that if the zeta, we will consider the reference value 1. If the zeta value is greater than 1, what about its damping value? The damping value is greater than 1. So that is over damped. The damping value is over in the system. During that period, the system poles, these two poles are located in real part of the system. Okay, the poles are located in this location, real part of there is no complex conjugate value, real part of the system. So think about that. Over damp, that is damping value is greater than 1, then it is the over damp system, and it has two poles. Those two poles are located on the axis itself, real axis itself. And in the case of between 0 to 1, if the damping value is between 0 to 1, it is called as the underdamped, overdamped, like that overdamped. Here the underdamped, the poles are two complex conjugate poles. So the poles are located in real number as well as the complex number. So poles are located in these two quadrants of the gas plane. Okay, and undamped, if the zeta value is 0, so the damping is no more there in the system. Okay, so in that case, the poles are located on the imaginary axis itself. Okay, it is the undamped system, and the poles are located in real pole but same location. That is the critical damp. If the zeta value is 1, it is called as the critical damp. The poles are located in same location. Okay, so this is the 4 different categories of the second order systems, and consolidate figure for that different categories. Okay, so zeta is 0, it is the undamped. The oscillation for the step input, unit input, the oscillation behavior is like this, that is sustained oscillation. If zeta value is lesser than 1 as well as greater than 0, it is the underdamped, oscillatory behavior is there. If zeta value is equal to 1, it should be like as the first order system response, and if zeta value is greater than 1, it should be like as the first order with lag response. Okay, so this is the different categories of the second order system with respect to the damping factor. Okay, so the S-plane locations depends upon this value, that is in here. Then you will consider omega n root of 1 minus zeta squared is the imaginary part value. This is the magnitude. Z omega n is the real part value. This is the range for that real part value from this. So it is related for that S plane. It depends upon that fold, we can find out that theta. It is an example one. Determine the undamped natural frequency and damping ratio of the following second order system. Yes, good. What is the standard transfer function? Function is omega n square divided by s square plus 2 zeta omega n s plus 1. Yes, not 1. S plus 2 zeta omega n s plus omega n square. So the omega n square is the 4 in here. So you can easily find out that omega n. 2 zeta omega n is the 2 in here. So if you are finding out the omega n, easily find out that zeta value. Okay, this is a procedure for finding out that omega n is 2 radian per second and zeta value. Yes, good. 2 zeta omega n is equal to 2. So by using this formula we can find out that zeta value also. This is the response. It is the overdamped system or underdamped system? Yes, underdamped system, because the zeta value is in between the 0 to 1. So that's why we are getting this output as oscillatory behavior. Okay. So it is a MATLAB response. Remaining 3 problems we have to do and find the response for the same. It is example 2. This one is what is the zeta value? What is the omega n value? 4. 16, isn't it? So omega n is 4. 2 zeta omega n equal to, yes, 0. Then zeta is 0. Zeta is 0 means there is no damping, isn't it? Undamped system. So you have to do the MATLAB simulation for undamped system, as well as this one is omega n is 2 radian per second zeta value. So you have to do this also, and you have to do this also in MATLAB and find the output graph. Okay. And one more thing, you have to group the particular transfer function with the particular response. In that aspect also, in public examination, government examination, they are asking the questions. Okay. So hope that you may have a little bit enriched this second order system as well as its categories. So the categories are based upon that zeta value. Zeta is nothing but the damping factor. Okay. Thank you for your listening. So you have to do this one and match the individual groups. Thank you for listening. Thank you.